Good morning. Good morning. Okay. I think last day we are discussing about our light. Am I right? The defects of eyes. Yeah. Okay. Fine. So almost we reached end of this chapter. That's the chapter we have to learn the major concepts in our chapter light. Okay. Now, actually we have one more chapter to discuss. It's about our celestial bodies and all. I'm not picking up the chapter today. We'll take it up in the month of February. Maybe it's the last chapter. So I just want to go through a recap of all other chapters what are already discussed in a short ways. Maybe I will go the gist of the chapters. What are the important terms we have to keep in mind when you are learning physics? That's all. So from this 8th grade, am I right? It's 8th or 7th, this one? 8th grade. So from this 8th grade physics, when you leave to 9th grade, what are the concepts should be in your mind? That is the discussion. At least you have to know very clearly some definitions and some understandings. So I just want to fix that part now. I start with, yes, of course you have already finished the chapters, I know, but I will go with a recap with my way of just explaining it. It may be a little fast because you have already introduced. Okay, so we start with force and pressure. That was the first chapter for you in this one. Today I am going to discuss about or define force. Wherever if you go, if somebody asks the question force, you can define like this. Force. If somebody says what is force? So force can be defined. Force is a cause. Force is a cause. Cause means what? C-A-U-S-E, cause means? Reason. Yeah, very good. The meaning is reason. So force is a reason that changes three things. Force is a reason or cause that changes shape of a body, then size of a body, and states of body or matter. I have told that when we use body, matter, substance, everything is identical terms. We have a lot of identical terms: body, substance, matter, objects. When we use these words, maybe mostly they are alike, similar terms, identical terms. So sometimes some teachers say body, it means something has mass and volume. Even substance, matter, objects. Don't be confused. It's all same. Okay. So force is a cause that changes. First one, shape of a body. Second one, size of a body. And third one, states of matter. That is the definition of force. Force is a cause that changes shape of a body, size of a body, and states of matter. Are you clear? That was the entire discussion of the first part of this chapter. Maybe the first 3 or 4 pages are repeatedly saying about this definition. They just explain to reach out or to come into this small definition. So, always when somebody asks you what is force, force is a cause that changes shape of a body, size of a body and states of matter. Very clearly we can get an example. Take this is a duster, it's a sponge, it's made up of sponge. I am going to apply force. What is happening? Yeah, shape is changed. Shape is changed. So with force, the reason behind this change in size is force. So we can define force. The first term, force is a cause that changes shape of a body. And if you take a rubber band or a spring and just pull it, what will happen? Size will be changed. So with force we can change the size of the body. And third one, we can change states of matter. When we say states of matter, I will have to add 2 terms. States of matter. What do you mean by states of matter? How many states are there for a body? Body, when I am say, don't take it as in chemistry language, we are talking in physics language. In chemistry language, states of matter is gases, liquids and gases, solids. Those are the 3 states of matter in chemistry. When we discuss in physics, what are the states of a body or states of matter or states of substance? There are 2 states. Yeah, direction is not a state. It is an attitude. See, I am a body. Now, what is my state? Okay, I am a body. What is my state now? Moving. So there are 2 states. What are the 2 states? Yeah. What is the right word for in rest or getting rest? What is the right technical term for a body is in the state of rest? Anyone? Come on. Pardon? Somebody is trying. Come on. Yeah. Yeah. I will add to you. It's a very common word. You are not recollecting right now. First state is state of motion. So there are 2 states of matter. First one is state of motion and second is state of rest or state of rest. If a body is in state of motion, it is known as moving body. A body is at motion. And if a body is in state of rest, it is known as stationary object. Stationary body. Have you heard this word? Stationary. Have you heard it? There are 2 stationary in our vocabulary. S-T-A-T-I-O-N-E-R-Y. Stationary. Stationary. Stationary means the goods, objects which we are going to stationary shop. Means a lot of goods are available there. Second stationary, stationary. This is we are using in physics. Means not moving. Are you getting me? Okay, good. Okay. So there are states of matter. So two states of matter: state of motion, state of rest. Is it clear? Then I am coming to the definition again. Force is a cause that changes shape of a body, size of a body, and states of matter. How force make state of matter? Think you are standing in a ground. You place the ball here. You place the ball here. The ball is now in what state? State of stationary. So stationary object now. State of rest. So stationary ball, state of rest. The state is state of rest or a stationary object right now. You just raise your legs and kick the ball. What will happen? It started to moving. So with the force you can change state of rest. State of rest to state of motion. Or you can move a stationary object to moving object. Am I clear? That is the first concept when we say it can change state of matter. Second concept, think there are another one is standing here. The ball is coming, now stationary to moving. Yeah, he with his foot, he stopped it. He has to apply force. Now it becomes again stationary or state of motion, state of rest. From movement to rest, moving object to stationary object, or state of motion to state of rest with the force. So he used the force to stop state of motion to state of rest. He used force to convert state of motion to state of rest. This person uses force to change state of rest to state of motion. So with the force we can change states of matter, means both it includes. We can convert state of motion to state of rest to state of motion. Am I clear? Yeah. That is the simple definition for force. So if somebody somebody is asking you, what is the definition of force? How can we define? Yeah, you can add together. No need of three things. Force is the reason. Very good, very good. Yeah, don't forget it. With the force we can change three realms, three areas. One is shape of body, change of body, and states of matter. When we say states of matter, we have to keep in mind that there are two states. One is state of motion, second one is state of rest. Am I clear? Very good. So never ever forget it. Because force is a very basic concept in mechanical physics. So when we go mechanics, this is the concept that we are using. Okay, fine. You have learned pressure? Okay, fine. So both are related terms. I just want to define pressure right now for you. Okay. When we take force, there is an identical term you can see. What is the identical term we can see for force? What is the identical term? It is thrust. Have you introduced the term thrust? Have you heard about this word? Respond me, please. Have you heard this word, thrust? No or yes? No. Okay, fine. Okay, thrust means if you I am going to do. Have you heard the term normal in physics? Normal. What is normal? Perpendicular. It is not actually a perpendicular line. It's a perpendicular axis. Means okay, imaginary line. That's a perpendicular. Perpendicular, 90 degree. Normal means in physics is 90. Something is acting on 90 degree. That is normal. Perpendicular effect or perpendicular line. If you just draw a surface here, how can we draw? If you see a point here, A, normal should be like this because it make a 90 degree. If you want to draw a normal, is it a normal? Is it a normal? No, it's not a normal. It's a normal because it always makes a 90 degree. Okay, fine. Are you clear with the normal? Okay. Then I am going to define what is thrust. Think a surface, a wood. Yeah. There are two persons are standing sidewise of this one. He has a sharpened object is here. He is try to pierce into the wood with a sharp edge. Another person also standing here. He is also holding a sharpened object and to pierce here. Okay. He is also applying force, trying to pierce into it. He is also applying a force. Is it clear? Both are applying force on this wood with this stick. Okay. What is the difference you have seen? Pardon? Angles. How he is applying? Normally. All are clear with that term now? He is applying normally, but he is not applying not normally. He is applying force but not normally. But he is applying force normally. Okay. In that case, I can define this person is applying force and he is applying thrust. So, here it has thrust. Here it has force. So, how can we define thrust? Here we can say he is using thrust. Here he is using force. So, how can we define thrust? Anyone try? Yeah, the force. Change the word perpendicular is a mathematical term. Perpendicular is a mathematical term. Yeah? Normally, the force experiences normally is known as thrust. Are you clear? Are you clear? Okay, so what is thrust? A force experiences on a surface normally. A force experiences on a surface normally is known as thrust. Okay? Is it okay? Yeah. So when you are standing on a surface, or you are sitting on a chair, how you are applying force? Normally. When I am standing, I am giving 90-degree force on my floor. So I am applying thrust. I am applying thrust over the surface. But don't be confused. Force and thrust are identical terms. Its values or magnitude, its unit, everything is same. But on the conceptual wise, when a force experience or exerts on a surface, normally it will be termed as thrust. If you say a force is applied on, no problem. But technically that is thrust if it is perpendicular, if it is normal. That's all. I think I am clear more than.
Yes, sir.
Okay, fine. Okay, from here we turn into pressure. So pressure can be defined as pressure is thrust per unit area. Pressure is thrust per unit area or force per unit area. So pressure P is equal to thrust by area, means if you take an object surface, if you take an object surface, yeah, the surface, I just applied force like this. I applied 10 Newton force. Is there effect? Is there effect? No. See? Effect? Yeah. I am applying 10 Newton force. Yeah, it is started to shrink. Am I right? Am I right? Okay, okay. So I applied force on this entire surface or entire area I have applied. Now think, I am using same force. Where is effect more? Now effect is more or less? More. So we are now also I am using 10 Newton force with my hand. In both instances, when I use this time also 10 Newton, when I use this also 10 Newton. But effect is more in second case. So what matters here? Area matters here. You got my point? If the area is more, effect is less. If area is less, effect is more. That's why how much force or thrust is experienced in your area is known as pressure. So in the first case, pressure is less. Second case, pressure is more. Means how much in first case 10 Newton force is applied on the entire area. The pressure, no, the thrust or force applied on a area. But here same force applied in small area. Pressure is more. So we have to keep in mind that there is a relation between pressure has two terms. One is the magnitude of force. Second one, the size of area. How much the area? Pressure is thrust per unit. How much force is applied on area is known as pressure. Is it clear? Okay, that's about pressure. So, in the practical sense, where we use this concept, area increases, pressure decreases. That's a note we have to get from here. Second note, area decreases, pressure increases. You have a lot of examples in your common life. First one, if you are walking with slippers, many are using slippers in home, and especially girls when you are going out with a fashionable dress and all. If you are in a great or gorgeous attire, they used to use high heel chapels or sandals. It may be like this come. My goodness, too much. I don't know how you people are managing to walk. Use high heel. Normal time you use a chapel. Flat chapels only. If you got a stamp with normal slippers or this one, high heel, maybe you are 14 or 13 years old, you just stepped over with a step over one's legs, and maybe a 5-year-old step with this one. Where should be more pain? High heel or slipper? High heel, because here area is very less. If area is very less, the effect is more. That we have discussed here. Area increases, pressure decreases, and area decreases, pressure increases. Is it clear for you? Yeah, we have a lot of practical examples we can see in our life. Maybe bags, carry bags. school bags. If strips are, if you're carrying a bag behind you, if its flips or straps are too thin, we can carry very comfortably, no more force will applied. But its strip is too narrow, what will happen? It make more pain. If you are lifting something with short thread and all, it will make, that's why we are using sometimes more broader straps and all, because area less, pressure. Even when pins, if pin has sharp edge, easily we can make the effect. If the pin has like this edge, not easy to, because area increases, pressure decreases. These are the some common examples and experiences in our life with this scientific observation. Okay. Okay, that's it for the day. We will continue the session. Like this, I will just cover the entire portions for you. Is it okay for you? Okay, thank you. May God bless you.